Hello and welcome to week one of a video series on teaching science in Idaho through the COVID-19 crisis. My name is Riley DeVito and I am the State Department of Education Science Coach. I'll be bringing you new resources each week, and really the whole goal here is to tackle science teaching during these unprecedented times and how we can reach all of our students and still offer them equitable learning opportunities. So for this week, we're going to be talking about offline resources and what you might consider, given that not all students have access to technology or that access is limited. A little bit about me, just so you know who the voice behind the mic is. I'm Riley DeVito, and I have a Bachelor's of Arts in Secondary Education and Biology from Idaho State University. I am graduating with my master's in this coming May from Boise State University. Go Broncos. I'm currently teaching at Notus Junior Senior High School, where I am the physical science teacher, which means that I have to teach pretty much everything between middle school and high school. So I teach earth science, physical science, AP Chem, AP Bio, forensic science, science literacy. I've also done student council and some pep club, board game stuff. So I wear a lot of different hats during my day, and I am really missing my kids right now. It's hard to not see them and get to have those connections with them. I also really like to travel internationally, so this photo was taken in February in Japan, just before all of the COVID-19 closures and travel warnings happened. So I'm really glad I got the opportunity to go on that trip and experience the wonderful country of Japan. I also really like hanging out with my cats, and I like to cook. Okay, so why offline science? What's the value of it being offline? For me, probably the primary and most important piece of this is that it's sparking our students' natural curiosity. They actually, they get to engage in the world around them right now. They get to go for a walk. They get to just look and see what's happening. They get to ask questions about things that normally they don't have the opportunity because their brain is so overloaded with everything that's going on. So we have an opportunity to harness that curiosity and really direct it into what does it mean to do science and to be a scientist. We also, with offline science, can accomplish a lot of things in regards to equity, because we have the opportunity to not just design lessons that are for students who have access to the internet, but also students who might have patchy internet access or no internet access at all and are relying in printed mediums to accomplish the work. I think that offline science also increases the engagement, because I'm sure, as all of you know, not all of our students learn well sitting in front of a computer and Googling things or typing things. They learn better with hands-on experience. So if we can get them away from the computer for part of their day and doing science, then we've accomplished a goal there. We also have an opportunity to meet our students' socio-emotional, mental health, physical, and academic needs. Hopefully as many of those as we can in one fell swoop. Right now, our students are obviously struggling with a lot of things, and in the classroom, when we're face-to-face with our students, we can accomplish a lot of the socio-emotional, mental, and physical health, but we can't in this digital format or this distance learning format. So if we can find ways to still do that, I know it fills my love cup as an educator, and I know it fills my students' love cups. So that's definitely a goal that I have moving forward. And then the last piece, which I'll hit on a lot throughout this presentation, is that we'll still continue to be teaching those Idaho science standards. Those don't get thrown out the window and we don't just forget about them. Like, we're still meeting the needs and the requirements that the state has for us as science teachers. So a couple of things to keep in mind just as we go through all of these options is think about how many choices and freedoms you can give to kids. You all know your communities, you all know your students and their families. What are some things that you can do to provide students the choice and the freedom to really experience science? And again, make it relatable and mean something in your community. Each of you has a unique and really cool place that you teach, with different sceneries and different animals and plants and people around. So how can you tailor some of these ideas to meet what you and your students experience daily? And finally, just keep in mind, and I know you all do, that kids are having a really tough time right now. They are struggling with the stress of a new system of school. Their parents are stressed out. Some of them are in situations that we can't even begin to understand. So just remember to have grace with our students when we offer these learning opportunities, and understand that a lot of them are doing what they can with what they have. Okay, so our a couple of ideas here. First 4 ideas would be the science journals, STEM projects, kitchen chemistry, and a science fair. All of these are really, really great by themselves offline. You can blend in some digital or make them totally digital, but they all can exist in an offline teaching world. And I will try and make this applicable to both secondary and elementary. But keep in mind, I am a secondary teacher. I will try and add in that elementary flavor as we go. So first up is the science journals, which my favorite thing about them is it's getting kids outside. They're engaging in real world phenomenon. They are actually participating in the world around them right now, which is a unique opportunity that we normally don't get when they come to school for most of their day. For part of their ELA alignment here, they're going to be keeping a daily, weekly, monthly log. They also can be doing reflections depending on how you want to approach that. And then the science journal really easily adds choices, it adjusts for students' needs, and it helps meet those Idaho State science standards as well. So here's a sample of what I've actually given to my students and what my students are actively working on right now is they have a weekly log where they have to keep track of what's happening. Most of my students are doing this Earth Systems option right here because I have them for 8th grade Earth Science. And you'll notice I put the 2 standards at the top that I'm really focusing on right now. And I anticipate changing that as we move. But for the first 3 weeks, I really wanted them to focus on that Earth, Sun, Moon system, and then evidence of weather conditions and air masses. So I have them collecting data on what they can without any technology. So what time did the sun rise, which that one requires them to wake up early, and hopefully that's a healthy mental and physical choice. And then they're keeping track of the weather, the types of clouds, which luckily we actually covered that before they left. So if your students haven't covered that, that could be something that you include in a packet that you're sending home, or if they do have access to the internet, that could be something that you encourage them to look up. They can be keeping track of precipitation, whether there's wind. My students also are very familiar with lunar phases and then what time the sunset is. I do have an optional thing down here for students who might want to go above and beyond that they can complete. And these would be things that they would really need to have digital access to in order to complete. So that's why I made it optional. I still made it to where students they can get 100% if they complete the required material, but they can get a little extra credit if they do this optional choice here. Here's an example of what you might do for life science. This, even though I have a high school standard listed here, this might be a little more elementary focused. Students keeping track of the number of animals they see, the types of animals they see, maybe if that animal is a predator or prey. And then I added some extra down here about like animal and plant phylum, and then structure function, just to meet some of those other science standards. So really just, if you're teaching life science, what can you do here that's very age appropriate? And finally, physical science. For this, I really found that I needed to have students just finding examples of it in their daily life. I found it really difficult for them to keep a log of like new and different things. So it's really just like, where have you seen chemical reactions today and physical reactions and examples of Newton's 3 laws? And I encourage my students to obviously find different sources for each of these things. So I don't want the chemical reaction one to be the exact same every day. I want to see some different things that they are actively seeing that science is all around them in as many different places as possible. So our direct learning opportunity here is really data collection. They are actively engaging with what is around them. They are observing and they are recording. Depending on what you then do with that, and you don't have to do anything with that, but if you wanted to, you could extend that to students analyzing and interpreting that data in the form of writing reflections or conclusions. They can mathematically represent or graph that using formulas or actually keeping track of things in a graph, which is a great skill for kids to practice. They can communicate that scientific information, so you can set up a way for them to maybe have a Zoom meeting with you or write you a letter of some kind about what they're finding. And then ultimately like drawing conclusions from their data, like what does that data actually mean? For the Earth system one, that could be, what does it mean when a certain type of cloud shows up and there's precipitation? Is there a relationship there? So just a couple of ideas on what you can do with the data that they've collected. Our next idea would be some STEM projects, which are great for hands-on building, problem solving, very kinesthetic learning for our like hands-on kids. And our ELA piece here is that students can keep track of their design process and do reflections through writing. And it also is a great opportunity for kids to brainstorm before they build their project. And might be a little familiar with this last bit here. It's easy to add choices, adjust for those needs, and it meets the Idaho science standards. When I create my STEM projects for my students, I approach it with sort of 4 steps. The first one being explain the learning outcome or the standard. So for example, one that I just finished accomplishing is how can you change one form of energy into another? And I wanted students to look at that from the lens of how can I change thermal energy, for example, into kinetic energy. So I explained to them, what does that mean? What does our standard mean? I did that through both like a video post to them, which I know is a digital format, but I also sent it home in their weekly description packets that our district is distributing. And then I designed the challenge specifically for them. I gave parameters, so what exactly I wanted accomplished, what the time frame was, what materials they could or couldn't use, and then I gave them creative license. So a lot of the things that I got turned in were pretty related to the project, but there were a few that the kids really, they just went off the rails and kind of did something, but they still were doing science. They actually still accomplished the standard. It just really didn't fit the challenge, but that's okay. And ultimately the goal was to get them to that outcome, and they did. So a couple of ideas for you for some STEM projects you might consider would be doing a paper airplane challenge, which could have stuff to do with like fluid dynamics. You could have students challenged for how far they can get the airplane, if there's upward pitch or downward pitch. And that's a fun one just for kids to build paper airplanes, because I know I love doing that as a kid. My students love doing that as well in class. You might consider them doing an egg drop and finding different ways to protect something. I know eggs are one of those limited items right now in grocery stores, so maybe you can think of something else that they can practice dropping. Rube Goldberg machines, which is actually what I used to accomplish that first learning objective and standard for my students. They can create a musical instrument, and that would all be about waves and sound. They can create a passive amplifier, so to amplify the sound of like their phone, if they wanted to listen to it louder but didn't have a speaker, what could they use or build around the house to make that sound larger? Maybe an unsinkable ship that they put in the sink or in the bathtub and try and put as much weight on it as they can before it sinks. So just a couple of ideas for some STEM projects that you might find useful. Our direct learning opportunity here is design, create, and construct. So again, that's that really hands-on element of science. And our applied learning opportunities, so what you might consider doing with that following the STEM project, so like a reflection, would be analyzing, interpreting what they collect, communicating that scientific information to you again, and then drawing conclusions from what exactly they accomplished during the project. Our third option is kitchen chemistry, which is great for everyday science at home. If kids are cooking, if they like to cook, if their family has access to that, this is a great one. The ELA component of that is that students are making predictions, they're justifying results, and they can write about those things. If you're familiar with CER or claim evidence reasoning, then this is a great one for students to be doing. And it easily adds choices, adjusts for student needs, and it meets the Idaho science standards. So for setting up a kitchen chemistry activity, do a little research. So if you want students to be getting the standard of chemical reactions, what are some chemical reactions that can easily be done in the kitchen? There are tons of labs online that you can Google. And when I'm researching these, I usually just type in what I want them to know, and then I include kitchen chemistry at the end, and I find really easy stuff. The one thing about this one that I will caution is make sure you're not putting too much stress on families for this one. A lot of families right now are struggling financially, or they are not willing to go to the grocery store and get supplies. So keep in mind that not all students are going to be able to do this option, but you know your community and you know your kids best. So I'll kind of leave that up to you on how that looks for you and your kids. Make sure that students are being safe with whatever they're doing in the kitchen. If it involves heat or burners or open flames or knives, just make sure that students are aware of the safety, because we still have that responsibility of communicating lab safety to our students. And then giving alternatives is really just, if a family does not have the needs to meet the kitchen chemistry, what else could a student potentially do to still accomplish the same standard? So a couple of ideas here, just some simple chemical reactions: baking soda and vinegar versus lemon juice and baking soda. The Maillard reaction, which is the browning of foods and why that makes foods smell and taste better, such as bacon or ham. They could do some things with cleaning supplies, and that really applies to what's happening right now with COVID-19. They can explore how does that actually work to kill bacteria and viruses. They can do a heating curve for boiling water for some of our more chemistry-minded people. They can look at coagulating milk and making yogurt and how that works. Just a couple of ideas that they might do for kitchen chemistry. So our direct learning opportunity is planning and conducting an investigation. They also, depending on how you want to follow that up, they are making and revising claims, making observations, collecting and interpreting data. If you're having students collect data, they can also graph and mathematically represent that. A lot of different things that we can do with this kitchen chemistry option. Our last option is an at-home science fair. The students can choose what they want, what interests them, what they have access to, and they get to explore it, which is a really cool opportunity for our kids. The ELA piece is that they can explore their science process and the process of being a scientist and write about it and brainstorm about it and put together sort of their like thoughts on that process. And finally, and this is I promise the last time I say it, is this really allows for a lot of choices, it adjusts to students' needs, and it meets those science standards. So for this one, first thing that needs to happen is students will choose a topic, and hopefully the teacher is supporting that in collaboration. And again, I don't know what kind of access all of you have to your students and how you're keeping in communication with them. So that might look different for each of you. You know, do what you need to do for that. Give some students the opportunity to explore those, or provide a list of topics for them when you send that home. But make sure that you're coming alongside during that process of choosing a topic. And then give some students guidance as they develop their inquiry. So what does it mean to put together a good experiment? What are some ideas that you have for putting together a good experiment? And send that with your kids or communicate that in however you're doing that. And give some students some time to collect their data, which actually is really nice for you as the teacher, because you're not developing a new lesson every single week to send home. There's actually time built in for them to just run their experiment and test it out. And then finally, think of a way that maybe students could present out or report to their family, to their siblings, parents, or like, again, write you a letter or send you a video clip if they have access to that about what the results were of their little science experiment. So a couple of ideas would be like maybe melting ice cream, get 4 different brands of vanilla ice cream and figure out which one melts the fastest, and maybe look at the ingredients and determine why. Make some mold in the fridge with some food that you leave in there for an extended amount of time. What do you see? What different things grow on different foods? I don't know if parents will be happy with that one, but it sounds fun. They could do a weather investigation, which would be a lot like the Science Journal, but they can tailor it to what they're interested in. If students do have access to technology, a metadata study would be really cool for some of your more analytical students. They can also do social science. So for example, driving with their parents to the grocery store and counting how many people walk in with a mask on versus not a mask on, or how many people sanitize their grocery cart, or something non-COVID related about how many people are at parks with dogs. So just some things that really, you know, deal with people that could be cool during this really interesting time that we're alive right now. So our direct learning opportunities would be planning and conducting an investigation. And then our applied learning opportunities are making and revising claims. So they can initially make a claim about what they think, their hypothesis, and then revise that as their study goes. Making those observations about their phenomenon, about what they're studying, collecting and interpreting that data. And again, you can include mathematical and graphical representations if you want to, and then communicating that scientific information in a way that works for you and your students. In conclusion, the big goal here with this information is we want to get students doing science and being scientists despite the fact that they're not in our classrooms and with us all the time. If we can support their creativity and their natural curiosity through that process, we're really benefiting them and their little scientific souls through this process and through COVID-19 and continuing their love for science. And finally, we are accomplishing what we as teachers and educators really have a deep passion about, is we are giving students an opportunity to learn. And whether they take that or not, you know, that's up to them, and it always has been, but we're giving them some really, really cool opportunities they can all accomplish and hopefully find some fun and some energy in. And lastly, if you need a thinking partner and you want to brainstorm some ideas, or this sparks something, or you still need some questions or clarification on stuff, I'm here for you. That's my job. I am totally willing to help you out. So you can shoot me an email at devito.idahosciencecoach@gmail.com, and I will get back to you as soon as I can. Feel free to leave a comment on this video as well, and I will reach out to you and make sure that I'm helping as much as I can and supporting you during these difficult times, So please, 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 if you need anything, reach out, let me know. And hey, we got this.